Hello and welcome all. My name is Ajay Gupta. I'm the senior consultant to Huawei in their Datacom products group. Today we're going to talk about Wi-Fi 6. As you know, Wi-Fi 6 standard is almost ratified. The commercial products have appeared on the market. In fact, some of the cell phones released just recently have got Wi-Fi 6 connectivity. So the question that's actually grappling the minds of CIOs and CTOs, how should they plan for Wi-Fi 6? What should be their strategy when it comes to digital transformation? Can Wi-Fi 6 live up to its hype? What happens to their Internet IoT strategy? So to answer all of these questions, it's my pleasure to invite two of the industry veterans here. I'm joined by Rohit Mehra, the Vice President of Network Infrastructure at IDC, and also from Huawei, Osama, who's the chair of A22.11ax. So without any further delay, I'm going to hand it over to Rohit to look at the market and what's going on in the marketplace. Rohit?
Thank you, AJ. It is indeed my pleasure to join you and Osama for this webinar where the topic for today certainly is top of mind for me and for a lot of industry watchers as well as enterprise IT professionals in terms of where and how to start with Wi-Fi 6 and for some even when to start with Wi-Fi 6. So certainly from an enterprise wireless standpoint, I do feel that Wi-Fi 6 brings a new era in enterprise networking and specifically enterprise wireless. So I'll just jump into some of the content that I have for you for folks who are listening in to this webinar today. I want to start about just taking a step back and looking at what the industry is walking through in terms of the digital transformation steps that many CIOs are considering on a regular basis, and what this means from a network perspective. As I have said many times before as well, for most enterprise IT organizations, digital transformation is a major step forward in terms of enabling the enterprise to really leverage some of the digital aspects and really embrace them from a business standpoint. But I've also seen that the network needs to transform if digital transformation needs to have and provide the right results. So from that perspective, I would think that the network, I do consider that to be a foundational layer to enable secure, scalable, and efficient use of all the cloud and edge applications that are becoming pervasive in the enterprise, and increasingly IoT applications as well. So from a connectivity standpoint, sure, the network needs to provide and optimize that connectivity and provide a secure platform so that the enterprise can really provide that good best-of-breed application experience. But from a network, if we go deeper into what is happening with the network and what kind of requirements is the industry seeing, the slide that is in front of you now, it basically provides a three-dimensional view of some of the network requirements as we see them emerge. The industry is looking for really fast and adaptive networks, and in many cases, on-demand capacity. You're also seeing with the advent of cloud applications that the edge to cloud latency is starting to have a major impact as well. And from that perspective, network level latency is becoming equally important. Then of course, from an analytics perspective, the ability to provide new insights from your wireless network is another key aspect of what the network needs to provide. And then, of course, from an industry perspective, look at some of the applications. we are seeing virtual reality play a significant role in some of the new age applications that enterprises are deploying. In education, in shopping, in travel and leisure, and even in healthcare, where telemedicine is starting to make inroads, we see the network playing an increasingly important aspect of technology. From a financial industry standpoint, and even from a cloud, back to the same discussion about cloud, we are seeing applications where latency in milliseconds is becoming an important aspect. So if we thought of in the good old days, a few seconds wait was not a big deal. Today, 5 to 10 to 15 milliseconds is the kind of wait that any application is going to require to be able to provide that good user experience with the many applications, cloud or IoT applications that we have come to expect. So from that perspective, moving on to this next slide that you see in front of you, I think of cloud and edge IoT as two key major industry advancements that are actually making the need for pervasive Wi-Fi even higher, and providing that impetus for networking professionals to go to the next step when it comes to Wi-Fi and other networking technologies. So as you see on the left, cloud, the increased use of enterprise cloud applications and SaaS applications has really made this a key industry requirement where any remote user, whether you are in an enterprise branch or remote or any off-site location, you want near instant access to your SaaS applications. And again, you want these access to be secure along with high bandwidth access for an enhanced user experience. Now switching to the other side of the coin, when you start looking at IoT applications at the edge, the digital transformation use cases are actually quite a few, and they continue to emerge on a regular basis in recent times. So when it comes to whether it's healthcare, mining, manufacturing, there's lots of IoT applications that are in many cases mission critical. They do require a resilient, low latency application experience, and therefore that has been the big driving factor for continued innovation on the Wi-Fi side. And of course, we moved through many standards over the years, and I'll talk about that in a second, that the drivers are definitely in place as innovation brings newer and newer capabilities to wireless networks. There's increasing use cases that keep coming forward, and the industry, of course, stands to benefit from these newer innovations. So just to give you a quick recap, I won't belabor this too much, but for those of us who have been in the industry for long enough, certainly I've seen the evolution of various Wi-Fi standards over the last decade and a half or so. If we just go back, I won't take you too far back, but if I look at the market for 802.11n technologies, when that was sort of fourth generation Wi-Fi in the 2000 to 2007 to 2009 timeframe, and it was both in the 2.4 and 5 gigahertz. That was the first introduction the industry saw for MIMO, and watchers believed that that would be the standard for a long time to come. But lo and behold, a few years down the road, we saw the emergence of AC Wave 1, which actually broke the gigabit Wi-Fi barrier for the first time, and it allowed multiple streams, Wi-Fi streams, to a single user. More recently, the standards have evolved to Wave 2, which, by the way, is the de facto standard in the industry today. Most enterprises have been leveraging that, and it's deployed fairly widely. Whether you go to any university or large public venues, you're going to see really hundreds or thousands of clients all supporting Wave 2 today. And the key benefits of Wave 2, of course, were the ability to have multiple download streams to multiple clients, and all clients getting the benefits of that capacity at the same time. The one downside, of course, was that Wave 2 provided wireless in the 5 gigahertz band only. So it did meet some of the requirements, but again, it wasn't quite universal in terms of the vast requirements that we are seeing in the industry. So when you start looking at dense requirements, we feel that even with AC Wave 2, the industry needs to make some progress. You need the higher performance and resiliency, especially at the edge, where IoT requirements are pretty stringent when it comes to low latency, et cetera. So from that perspective, the drivers are well in place for what we are calling in the industry Wi-Fi 6. So just to give you a quick recap, I've talked a little bit about some of the capabilities, but Wi-Fi 6, which in the industry many of us have referred to as 802.11ax, and I know Osama is going to talk about extensively about the same technology. But some of the key highlights are that the operations are in both 2.4 and 5 gigahertz. That's a major step forward. It really makes dense Wi-Fi environments more enterprise grade. And I think that is a major step forward. The ability to support IoT use cases, even simple things like the ability to improve power efficiency of the various user devices, and that bringing that to the Wi-Fi world will allow all kinds of new devices and sensors to leverage the power of Wi-Fi, which we have not been able to do that from an IoT standpoint. And again, improve average performance or per station or per device is another key aspect of Wi-Fi 6, which I think will propel the industry forward. From a use case standpoint, and I'm moving to this next slide, and you can see a few nice pictures here, but I think the pictures will speak 1,000 words themselves. But think about all the dense applications for wireless, highly dense sports stadiums, conference venues, and even at the bottom right, auditoriums, in an educational environment where large campuses have students all concurrently wanting access, but also trying to look at a collaboration and a multimedia type experience on their Wi-Fi devices. Wi-Fi 6 will be a major enabler. Some of the other mission-critical applications that I've seen are in areas like large enterprises, healthcare, and I would say more recently, from an IoT standpoint, if we start thinking in terms of the shop floor, the manufacturing shop floor, you'll find they will benefit a lot when it comes to Wi-Fi 6. So with that, I'm going to hand this off back to AJ. And I know, AJ, you have a couple of questions for me.
Oh, absolutely, Rohit. Thank you so much for that insightful presentation. So we've been talking to our customers, and some of the key questions, in fact, they have been asking us, based on what you just presented, it looks like Wi-Fi 6 is not an option. It's almost becoming a must in some of the scenarios and use cases you presented. The question for the customers are asking, should they wait or should they upgrade now to Wi-Fi 6? What should be their strategy when it comes to planning for the Wi-Fi 6?
I think that's a great question, and we speak with enterprise IT professionals and CIOs around these technology upgrades fairly often. And I do think that Wi-Fi 6 is now, though it will get ratified later in the year, it is at a point in time where the industry starts to look actively at deployments of Wi-Fi 6. Now, again, you might want to evaluate what currently is deployed in your current network, right? If you are using legacy networks, I see no reason why you would want to wait. especially if you are with 802.11n technology that you never upgraded to AC. That's fairly straightforward determination that you need to move right away. Now the question is, if you have AC wave 1 or wave 2, what exactly? So I think those are areas where we advise clients to have a look at, are you using first generation of AC? Do you have AC wave 1? How active are your clients, and what are the typical use cases that you want to deploy this for? There may be some scenarios where even with an AC wave 1 environment, which might be 3-4 years old, you might be seeing a business case to move to Wi-Fi 6. But in other cases, if you have AC wave 2, they're all deployed within the last couple of years, probably you could wait another year or two and then start to think about rolling out Wi-Fi 6.
Great. I know you touched upon IoT, but one of the questions that has been coming again, as you know, 5G is coming. We've been hearing a lot about 5G every day. The thing that we've been asked over and over again, how would you really kind of put together 5G in the context of Wi-Fi 6? Can they coexist? How can they leverage each other going forward, actually?
That's a great question. It so happens that Wi-Fi 6, which is the new emerging standard for Wi-Fi, and the new cellular standard, 5G, are seeing this emergence almost in parallel with each other. I just got back from Mobile World Congress, and the use cases for 5G were pretty significantly talked about by a number of operators. So I do feel that these are technologies that actually will leverage and work to each other's advantage in many cases. I don't think people should be thinking in terms of, is it one or the other? Not really. Wi-Fi 6 is an enterprise use case. It's unlicensed technology and will become pretty pervasive, from mobile devices to laptops to all other mobile devices that are Wi-Fi enabled, including many sensors in the IoT space will all be enabled with Wi-Fi 6, right? Whereas on the cellular side, gradually the path will mature towards devices moving from 4G LTE eventually to 5G. I think I couldn't say it better. I think the way to look at this is both these technologies will be better together. The backhaul will mostly be, in the coming years, will be handled high capacity, low latency performance on the wide area network with 5G, but all your local area networking needs with Wi-Fi and mobility are going to be met by Wi-Fi 6.
Great. And lastly, actually, another question. Does Wi-Fi 6 help create new business models? I'm thinking of some of those immersive applications, AR, VR kind of thing. Do you think the enterprise customer, does it trigger some of the new ways of making money kind of thing?
I can see the writing on the wall when it comes to use cases.
Right.
And there will be many. I think IT and network managers need to take some time, take a step back, actually experience the power of Wi-Fi 6, which may happen over the next year or so. And once they see the performance, the resiliency that Wi-Fi 6 brings to the table when it comes to these network environments, the use cases will flourish. Whether it's healthcare or large public venues and airports, etc., the applications will emerge pretty quickly, both from an enterprise standpoint, the corporate enterprise, but also in terms of a large number of IoT use cases.
I'd like to invite Osama to go over some of the technologies, some of the innovations that Wi-Fi 6 brings to the table in the market. Osama?
Yeah, okay, thanks, AJ, and I'm glad actually to join you and Rohit in this event. As AJ mentioned, I'm going actually to focus on the technology itself for Wi-Fi 6 and also on Huawei's role supporting this development. So the Wi-Fi 6, maybe the first question is why Wi-Fi 6 or 11ax and where it came from? Wi-Fi 6 actually is the answer to a very real problem that was observed in the market regarding the Wi-Fi deployments in the past. Wi-Fi, when it started, actually, it was very popular in small offices and consumer homes, like the residence Wi-Fi. And these cases actually characterized by a small number of users, maybe actually one user per AP in the extreme case. And the APs, the access points, were naturally separated by walls, by different houses, and it was mostly indoor, actually. Around 2013, there was a visible shift in how Wi-Fi is deployed. So basically, it left these old markets and was deployed actually everywhere, in stadiums, in airports, in large offices, in colleges, everywhere actually. And this, of course, use cases is characterized by large number of users and large number of access points as well, situated in a very close distance. So at that time, actually, the idea was the new use cases actually are characterized mainly by large number of users and what we call dense deployments. So that's actually the origin of Wi-Fi 6. And from the start in Huawei and other places as well, we thought that this Wi-Fi 6 or 11AX need to be different from the previous Wi-Fi generations, like different from 11AC, different from 11N. 11AC and 11N, the focus was mainly on increasing the throughput, increasing the total throughput. So if you and I are sitting in a Wi-Fi in the same access point, it doesn't matter how much I take of the throughput or how much you take. What's matter actually is that the total throughput achieves certain level, like 100 megabits per second for 11N, or at least 1 gigabits per second for 11AC. Here actually in Wi-Fi 6 is different because it emphasizes user experience. And the main actually performance indication is 4 times improvement in the user experience or user throughput compared, of course, to 11N and 11AC. And this is actually a main difference and was like a shift in how the standard for Wi-Fi is developed by looking at these user throughputs, especially to those users that sit at the edge of the cell. So everyone needs to see some improved performance and certain level of throughput for everyone. What does Wi-Fi 6 bring? This is compared to Wi-Fi 5 or even Wi-Fi 4. This is a very actually summary slide. It brings actually high bandwidths. It's higher throughput than 11AC. 11AC, the highest throughput, as I have actually a slide on that, is about 6.9 gigabits per second. Wi-Fi 6 or 11AX goes to 9.6 gigabits per second. It has large capacity actually by introducing 1024 quadrature amplitude modulation. This is basically having more signal packed in the same space, so it actually can achieve larger capacity. It has a low latency by multiplexing a number of users on the frequency domain. The delay performance of Wi-Fi 6 is lower than that of Wi-Fi 5. And it also introduces mechanisms in order to help the devices to save power. So there is some mechanism that's called target wake-up time. Target wake-up time is actually very similar to how we do things in everyday life. It's basically an agreement between the access point and the client or the device that the access point is going to offer its service at certain point of time. So the device actually can stay sleeping until this time comes up and switch to the active mode and communicate with the access point. So there's lots of power save in this respect. The next slide, actually, this shows some details of why Wi-Fi 6 is better. And here, actually, this slide summarizes a number of the features that make Wi-Fi 6 better compared to Wi-Fi 5 and Wi-Fi 4. The first one is the band, and the band, of course, is very important. So Wi-Fi 6 comes back to the 2.4 and 5 gigahertz bands, which are the traditional bands for Wi-Fi, and it's similar to Wi-Fi 4, and Wi-Fi 5, of course, is only in the 5 gigahertz. But more important, actually, is Wi-Fi 6 is designed to operate in the 6 gigahertz band. This is actually a new band. It's not available now, but it's expected to be available maybe by the end of this year. And this is actually a very large very large amount of spectrum available. I think in the US, it's about over 1 gigahertz available. And basically, actually, the Wi-Fi 6 can operate in this wide band. It can actually reduce the delay for waiting for applications, and of course, can make use of the wide band and having more channels available. The next thing is the waveform, and again, Wi-Fi 6 distinguishes itself by having OFDMA, or orthogonal frequency division multiple access. This actually adds another dimension compared to 11AC, for example, for multiplexing more users. So with Wi-Fi 6, more users can be multiplexed on the frequency domain, and allows the AP to schedule users based on their requirements in terms of delays, occupancy, buffer fill, and things like that. Channel widths, there is no change in Wi-Fi 6. It's similar to 11AC. Number of antennas still same as 11AC. The advanced power save is important. Wi-Fi 6 introduced a new mechanism called target wake-up time. I talked about that briefly. Basically, it allows the access point and devices to agree on when the service is going to be received from the AP. So the device actually can go and sleep until this time comes up, and then it wakes up and go to the active state and receive or send information to the access point. This, of course, helps in power save. And battery life, of course. The aggregate data rate, there is about 40% increase in the data rate, and in the highest data rate achieved with Wi-Fi 6. So it can go up as 90.6 gigabits per second. Next subject, actually, or next point is user experience. Experience is very important. This is what Wi-Fi 6 is designed for, to improve user experience. And every user actually should roughly see like 4 times improvement in the throughput compared to 11AX or 11N. For Wi-Fi 5 and Wi-Fi 4, you cannot actually talk about user experience. They are not designed for that. They designed for the aggregate link throughput. So they do not look at the user, every user performance. There is actually a mode in Wi-Fi 6 called the 20 megahertz only operation, and this actually can operate a device, Wi-Fi 6 device, only supporting 20 megahertz operation. And this is actually suitable for IoT applications where less power is consumed when you support 20 megahertz, and it's expected actually that Wi-Fi 6 will play a major role in IoT applications. Next feature is spatial reuse. This is actually unique to Wi-Fi 6. Spatial reuse, it's if you have 2 persons sitting beside each other and they start talking at the same time, both they interfere with each other. But if they are separated by reasonable distance, maybe there is no much interference between the 2 of them, and they can speak at the same time. So this is actually the idea behind spatial reuse. If the interference from one AP to the other AP is not as high and within the noise margin, they actually both APs can speak or can transmit information at the same time, and this way actually they can achieve higher throughput by efficiently using the available spectrum. Multi-user MIMO, we have downlink multi-user MIMO, same as in 11AC, but also Wi-Fi 6 adds what's called triggered uplink multi-user MIMO. So this is basically actually triggered by the access point, and this is why the access point can actually schedule devices based on their requirements to transmit in the uplink direction. The performance of Wi-Fi 6 for outdoor operation is improved by adding few things. like the mid preamble, for example, is one of them. Of course, for Wi-Fi 5 and Wi-Fi 4, there is no particular mechanism that was added to improve performance in the outdoor. And finally, adding more dense modulation. This is actually the QAM, or quadrature amplitude modulation. It's packing more signal in the same space, so you can achieve actually higher throughput. And Wi-Fi 6 is probably the first in the industry, in wireless industry in general, to introduce the 1024 QAM. This slide actually is just to illustrate the new spectrum and how wide it is. And as I mentioned, this spectrum actually is expected maybe to be available by end of this year. So you see actually there are many 20 megahertz channels that can Wi-Fi 6 actually can benefit from. And actually, it led actually to some people even thinking about increasing the bandwidths beyond the 160 megahertz to 320 megahertz. But I just wanted to give an idea of how the new band can actually help the performance of Wi-Fi. And Wi-Fi 6 is the only Wi-Fi technology right now that can work in this band. This slide actually is to focus on Huawei effort promoting the development of Wi-Fi 6 standard. Actually, Huawei realized early on the need for new Wi-Fi standards, and Huawei has committed the resources to be an effective participant in this effort. The result, actually, of course, is we have a very good number of submissions to the proposals, to the committee and the task group. And one company, actually, as you see here, submitted 25% of all the proposals, which is a very good number. Of course, Huawei has chaired the 11AX since the start of the task group and continue to do that, and will continue to do that until the standard is ratified and published. Huawei also has produced the product itself to support Wi-Fi 6. I think it got released maybe early last year, and it's seen actually large popularity with customers. It can support Wi-Fi 6, fully support Wi-Fi 6, can support up to 400 users, and of course, much improvement is expected in the future. So to summarize, I think Huawei took the lead in definition of the new Wi-Fi standards. I also would like actually to emphasize that Wi-Fi 6 is expected to be the backbone of any standard that will come, any future generations or future enhancements to Wi-Fi standards. So by investing in Wi-Fi 6, you actually invest in the future. It's not, it's money well spent, let's say, because it's really going to be the backbone or the infrastructure for what comes next. Everything is going to build on top of Wi-Fi 6. So the enhancements, as I mentioned, with the addition of the new band, may include 320 megahertz channels, and may include also a larger number of antennas beyond 8 antennas. And finally, Huawei has the resources, it has the people, it has the product to positively influence future Wi-Fi directions, and we intend to do that.
So do you think, would it be fair that Wi-Fi 6 is not just a simple upgrade of features from Wi-Fi 5, it's a completely leapfrogs the Wi-Fi technology to the future? Would that be fair to say that?
Certainly, yes. It's not just like if we look for 11N and 11AC, for example, 11AC was just an enhancement to 11N, but the main structure or main ideas were similar, actually. Wi-Fi 6 is totally different because, as I mentioned, it actually used a different waveform of DMA compared to OFDM. So it's really a change, a big change from what was available before.
Great, great. One of the very common questions that keep coming is this, the backward compatibility. The products supporting Wi-Fi 6 are just starting to appear in the market. The terminals, the STA still don't have the Wi-Fi 6 connectivity. So what would you suggest to our customers who are thinking of putting Wi-Fi 6, but they're not too sure that is it too early in terms of backward and having simultaneously Wi-Fi 5 and Wi-Fi 6 networks together?
Yes, thank you, Ajay, for this question. It's a great question. Yes, actually, in Wi-Fi standards, and all of them, they were designed with backward compatibility in mind. So we have actually 11AC, 11N, 11AX, or Wi-Fi 6. Wi-Fi 6 is backward compatible to both of them, actually. So in the sense that if you have, for example, an 11AX or Wi-Fi 6 access point, and you drop an 11AC device in the mix, it's going to see the service as if it's an 11AC environment. So it's totally backward compatible. So this is actually good news for the customers as well, because they can actually upgrade their network gradually. So it doesn't have to be a forklift of everything and replace everything, but it can happen gradually, maybe first having, I don't know, in certain areas Wi-Fi 6, and then followed by other areas and so on.
Yeah. Oh, that's a fantastic news. Absolutely helps our customers to really kind of start thinking about the Wi-Fi 6. I mean, lastly, one of the things, I know you were the chairperson for the IEEE 802.11ax working group. Does Huawei has any representation on the Wi-Fi Alliances group? I mean,
Yes.
where we are?
Yes, actually, just to differentiate between Wi-Fi Alliance and IEEE 802.11, 802.11 generate the standards. It's mostly technical work. Wi-Fi Alliance is probably the marketing. There's no direct relationship between them, but Wi-Fi Alliance focus more on Wi-Fi market. And yes, actually, Huawei sits on the board of directors for Wi-Fi Alliance. So this is the highest level of membership in Wi-Fi Alliance. It gives Huawei, of course, a voice in where the direction of the market and where the Wi-Fi Alliance is going in approving projects and all this stuff. So we really have a very effective voice on the Wi-Fi Alliance. We also have a number of chairs and vice chairs in different task group. Maybe one of them relevant to Wi-Fi 6 is the vice chair of Wi-Fi 6 certification at Wi-Fi Alliance. So we are actually as active in Wi-Fi Alliance as in 802.11.
Great, good to know. Thanks, Osama.
Yep.
All right, now you've seen the market, you know where Wi-Fi 6 stands, you've seen the technology, the nuts and bolts of where we are on Wi-Fi 6. Let's talk quickly on the different innovations and the product and solutions portfolio from Huawei. Before I go there, let me just kind of put the whole thing. Wi-Fi has now become a foundation technology. There's no question about it. In fact, I would like to refer to a study that was done by Wi-Fi Alliance in last year, 2018, where they put the total economic value of the Wi-Fi as $1.96 trillion, which is expected to reach to $3.96 trillion in next 4 years by 2023. So there is no question in anyone's mind that Wi-Fi, and especially now Wi-Fi 6, almost become a mandate as they start moving towards digital transformation. Over the years, as Rohit and Osama explained, as the Wi-Fi technology evolved, there has been an increase in the data rates, throughputs, and capacity. But of late, data rates, capacity, throughput has become a table stakes. The major problem that's really coming up, what happens when there are multiple people accessing the network at the same time? You can just look at your household. One kid may be accessing the Netflix, other kid may be doing some video streaming. So as more and more people start crowding the airspace, the major challenge was how do you take care of the dense environment, and that's where Wi-Fi 6 really shines. Let's look at the challenges on the WLAN and Wi-Fi network on this slide here. Look at the different user scenarios that Rohit presented earlier. For example, in manufacturing environment, we want to make sure that there's a continuity when it comes to the service, the latency that is required, for example, in your automated guided vehicles, in warehousing has to be below, let's say, 10 milliseconds. The stability needs to exceed 4 nines or 5 nines. We talked about the IoT networks. IoT is one of the killer applications, if I can say so, for Wi-Fi 6 networks, because some of the features like TWT that we talked earlier lends itself to the Wi-Fi, to the IoT devices, especially in the 20 megahertz bandwidth. At the same time, we want to make sure that there is a minimal interference if we're using both Wi-Fi 5 and Wi-Fi 6 networks together. So you need to manage that network. You need to be able to see what's going on. So you need a network that is highly stable, low latency, highly concurrent actually, and low performance consumption. And that's where Wi-Fi 6 really comes into the picture. Let's look at this on this slide, the very unique advantages. We all talked about the bandwidth. The bandwidth almost quadruples, as Osama referred to earlier. In applications in venues like stadiums, in supermarkets, in auditoriums, in malls, in train stations, it is imperative that Wi-Fi 6 almost becomes a mandate because of the number of people trying to access the Wi-Fi network at the same time. You need a concurrency of maybe up to 400 terminals per access point. In e-learning, when you're using AR, VR, as teachers are getting rid of the textbooks and they are bringing more augmented reality, virtual reality, even mixed reality, the bandwidth becomes really an issue. So as you start moving towards 4K, 8K, and UHD kind of content, you need a network that supports Wi-Fi 6. And obviously, latency, we talked a lot. You need a latency less than 10 milliseconds in applications like AGV in manufacturing. So as you start moving towards Wi-Fi 6, there are many benefits and features that Huawei has innovated on top of the standard 802.11ax. And one of the technology and one of the new innovative features that we brought is using what we call smart radio. There are many things like, for example, intelligent roaming load balancing, where AP can really switch from one device to another bandwidth based on the signal. Dynamic frequency adjustment. If the signal is weak, the frequency can be adjusted. But one of the features that stands out is what we call lossless roaming, actually. So in the traditional case, what used to happen is access controller, before it moves to the new link, it's gonna disconnect the original link and then connect with the new, then establish the new link. But what happens during the process is there is a packet loss. And that is really not warranted in very latency sensitive application. And what we do in the 11ax in Wi-Fi 6, using the smart radio, the new link is established before the old link is disconnected. That really gives you what we call a no packet loss technology built on top of the standard here. Obviously, we talked a lot on the IoT side. IoT application really kind of I would say almost is built for Wi-Fi 6. Huawei products have got both Wi-Fi 5 and Wi-Fi 6 APs have built in our external IoT card. We have a Zigbee, Bluetooth, RFID, and even UWB for the location finding. One feature obviously mentioned on this slide is what is TWT, as Osama referred to it. The device can schedule a time when it's going to wake up and send the data to the access point. That way, there's not contention for the media. The battery is preserved. We estimate by using some of this TWT function on the Huawei APs, almost more than 30% of the power can be saved here. Let's look at some of the O&M that comes from Huawei. Campus Insight, I'm pretty sure you are familiar with it. It's based on the big data, machine learning, and AI. The whole idea is to give you a refined O&M, as we call it, really kind of detecting the issue within seconds, giving you the complete visualization in the real time. Not only detecting it, doing the root cause analysis based, as I said, on the machine learning and AI-based protocols. And then once the issue is detected, we want to really fix that issue and making the network as more like self-healing. And then the next step is doing the predictive analytics based on some of these intelligent algorithms based on the Campus Insight. If you have not seen the Campus Insight, I really strongly urge you and encourage you to see a demo of the Campus Insight, and I think it's going to help you a lot to some of the IT managers that have been struggling for years to get the real-time analysis of the issues. Let's look at the Huawei's Wi-Fi 6 solution portfolio. Huawei has an AP called AP7060DN. AP7060DN, which has got a built-in antenna. The device can reach up to 6 gigabits. It's got the 4 times, as we talked about, quadrupling the capacity from the earlier standards. Massive, fast, and can support different user scenarios we touched earlier, whether you're talking high-density stadiums, auditoriums, etc., or you're looking for a high bandwidth in interactive, immersive applications, VR, AR, 4K, 8K UHD, or you're looking in the warehousing applications in smart factories. To support this AP, we also have fixed switches 6720SI that was also launched early last year. This is a truly first multi-gigabit switch. Has got the ports from 100 meg all the way to 10 gigi with an uplink of 40 gigi. All of this thing can be managed using the cloud managed network. And Campus Insight, we just talked about bringing you and identifying per user issues, proactively giving you the information for what might happen in your network. The data sheets and the information is available both on the access points and the switch on the Huawei website. Or you can always contact your local sales representative. With that, we come to the conclusion of this webinar, and we're going to talk a little bit on a final summary from Rohit, Osama, and then we'll close it out.
Yeah, okay, thanks, AJ. I think actually I would like to emphasize that Wi-Fi 6 provides a clear improvement compared to previous generations of Wi-Fi, and it's very essential for the digital transformation that is being seen by a number of organizations. I also would like to emphasize that a point that I made earlier, that Wi-Fi 6 is going to be the backbone or the infrastructure for what comes next. So it's really important for future evolution.
I do think that Wi-Fi 6 will usher in a new era of enterprise wireless. There's no question. Previous standards did bring additional innovation and newer aspects of technology that helped improve performance. Wi-Fi 6 takes it that extra notch further up, really providing not just for the broader enterprise, but I do think that it will open up newer avenues, newer opportunities, and use cases, more importantly, including enterprise and edge IoT use cases that we would not have thought of before this technology had come about. So really, I think this bodes well for the industry, but really it'll open up a lot of opportunities for enterprise IT and network managers as well.
Thank you, Rohit. So it is abundantly clear that Wi-Fi 6 needs to be taken very seriously. If you're not thinking about moving to Wi-Fi 6 in the near future, you should be thinking in terms of your strategy for your digital transformation and IoT. Wi-Fi 6 has arrived. We really think 2019 is going to be the year of adoption with a massive success in the next 2 to 3 years. As it was referred, Wi-Fi 6 is going to be the foundation technology for all the future technologies to come. So please start looking at the Wi-Fi 6 commercial available products and see how it can help you get onto the bandwagon of digitization. With that, that's a wrap. Thank you, Rohit and Osama. Really do appreciate your time. Thank you.